Let's start. In last class, I told you how state space representation of any discrete system from the first transfer function. So I have explained there is a four-way to represent any first transfer function to the state space. First one is called canonical canonical form. Second one is called observable canonical form. Third one is called diagonal canonical form. And fourth one is Jodal canonical form. And I have explained how you can write in the controllable canonical form, then observable canonical form, diagonal canonical form. Okay. And Jordan canonical form. And I have solved one numerical based on this problem, those theory. Now today I will start and the solution of discrete time state equation. Next topic is solution of discrete time state equation. So before going to the discrete time state equation, I will revise some point, that is how you can find the solution of state space in continuous time domain. Okay, so what suppose you have one equation dot x dot is equal to, in continuous time domain, x dot is equal to ax plus bu and y is yt is equal to cx plus du. Okay, okay, then uh, then you can say that the solution of state space equation, that is solution of state space is called in continuous time, that is x is equal to e to the power at x 0 plus integration from 0 to t e to the power a t minus tau b u tau into d tau. Okay, and e to the power at is called state transition matrix, yes or no, and its value is equal to inverse Laplace of si minus a inverse. Okay, it's called state transition matrix. Okay, any doubt? Now if you move to the discrete time system, so you know the in discrete time system the state space and the output equation are, suppose in the discrete time, so it's in the continuous time, okay, and the discrete time, suppose in discrete time state equation are that x k plus 1 is equal to g x k plus h u k, and yk, that is output equation, is equal to c x k plus duk. Okay, so now we have to find out the solution of state variable in discrete time system. So first, for the solution of this state space of discrete time system. So first you have to put k is equal to 0. You want to find the solution. So then x1, that is x1 is equal to g x0 plus h u0, and if you put k is equal to 1, then x2 is equal to g x1 plus u h u1. So in this way, now you know the value of state discrete state variable at k is equal to 1, and now you can put the value of x1 in the equation 2. Then you can find out the value of x2. So in this way, if you write the equation, then the solution of state variable in discrete time, that is equal to g of k x naught plus summation j is equal to 0 k minus 1 g k minus j minus 1 h u j. Okay, where k is equal to 1 2 3 dot dot dot. So this is the solution of any state space represent state space equation in time discrete time system. In discrete time system. Okay, if you compare with the continuous time domain, so in the solution of any state space in continuous time domain, that is x is equal to e to the power at x 0 plus integration from 0 to t e a t minus tau b u t tau and d tau. Okay, what is a? A is state matrix and b is input matrix. So now if you compare, with the with the discrete time solution of discrete time state equation, then e to the power at is replaced by g to the power k, and since discrete time have not in the continuous mode, that's why integral part is replaced by summation, that is summation start from j equal to 0 to k minus 1, that is in the continuous time integration from 0 to t, in the discrete time summation from j equal to 0 to k minus 1 g k minus j minus 1, that is again e to the power a t minus tau, and h, what is h? H matrix is equivalent to b matrix and uj is equivalent to u tau. Okay, so almost the solution of discrete state space equation are same as the continuous time domain. So now you know in a continuous time domain, e to the power at matrix is known as state transition matrix. So similarly, in the discrete time system, g to the power k matrix is known as hello, hello, I am audible to you.
Yes, sir.
So suppose in the continuous time domain, e to the power at matrix is known as state transition matrix. Similarly, in discrete time system, g to the power k matrix is known as g to the power k matrix is known as g to the power k matrix is known as state transition matrix. Okay, I think you are not interested, but I have to take your class and complete your syllabus. Okay. So, and what is the solution of output matrix? So if you put the uh, value of xk in the output equation, then output equation becomes c into g k x naught plus c into summation start from 0 k minus 1 g k minus j minus 1 h u j plus d u k. Okay. Okay. Now the definition of state transition matrix. So again, if you recall that if you recall in the continuous time domain, so from the solution point of view, we have classified the state space representation in the two way. First one is called homogeneous state equation, and second one is called non-homogeneous equation. So if there is h into u part, when x k plus 1 plus equal to g into xk, and there is no part of h into uk, then this type of state space equation is called homogeneous state equation. Okay. and and if the state space equation of discrete time system is equal to x k plus 1 is equal to g xk plus u h into uk, then is called non-homogeneous. So solution of homogeneous equation and non-homogeneous solution, that is solution of homogeneous state equation, there is only this part. Okay. And solution of non-homogeneous have two part, first part and second part. And tell me, uh, in the solution of state space equation, this part comes from initial value. That means it depends on the initial initial value of state variable, and this part due to input nature of the input applied to the system. Okay. So suppose in any system, if there is initial value is equal to 0, then this part will vanish. And if in any system that is for in the homogeneous system, if there is no relationship with the input, then this part is vanished. Okay. So this part is called natural response, and this part is called force response. Why is called natural response? This part is due to initial value of the state variable. How can you compare it? What do you mean by initial value of the initial value of the state variable? For example, in the RLC circuit, inductor have some initial current and capacitor have some initial voltage stored in the capacitor in the form of energy. So if you applied input force, so this part due to initial value of the inductor and capacitance, and this part depends on the nature of the input. So now what do you mean by state transition matrix? Definition of state transition matrix. So you know in the solution of homogeneous equation, that is x k plus 1 is equal to g of g into xk, then the solution of homogeneous state variable solution of homogeneous state equation becomes xk is equal to phi k into x naught. What is phi k? Phi k is known as state transition matrix. Phi k is known as state transition matrix. That is phi k is equal to g to the power k. So in case of discrete time system, state transition matrix is equal to g to the power k. Any doubt? Any doubt?
No, sir.
No. Now, so if you the next way to find the solution of uh, jet transform method, to the solution of discrete state equation. So first method, that is in the first method we have applied k is equal to 0, k is equal to 1. In this way we can write the general equation for the solution of the discrete time state equation. So next way to apply Z transform to find the solution of the discrete time state equation. So again, so you know the in discrete time system the state equation is equal to xk plus 1 h xk plus g xk plus h uk. Okay, so if you apply state Z transform to the equation, so it becomes Z into apply Z transform, then it becomes